So this is lesson 9, physical or chemical changes, pages 40 to 43. So we need to know what a physical or chemical change is. In chemistry, we need to know the differences between a chemical change and a physical change. So I've given you 2 examples here. In a chemical change, new substances are made. The change is not reversible. Energy is sometimes given out in the form of light or heat. The matter is conserved, so we don't make anything extra and we don't lose anything. For an example of that is burning. Now, if you burn a piece of wood, you cannot get that unburnt piece of wood back. You can't separate the compound that you've made back into the unburnt wood. In a physical change, no new substance is made. The change is reversible. Matter is kept or conserved. Again, you don't lose anything, you don't gain anything. But this time the change is reversible and no new substance is made. So for example, melting. You take an ice cube out of the freezer, and if it's left out long enough, it will melt. Have we made a new substance? No, it's still water. And to make it or turn it back into ice, we just put it back into the freezer. So it's a reversible reaction. So we're going to look at melting. Put an ice cube in a beaker, cover the beaker in cling film and then weigh the beaker. Leave ice cube to melt and re-weigh. So you've got some blanks there. There's some information on the next 2 slides that will help you answer those questions. So this is the initial mass of the ice cube. So this is what it is at the start. And you can see that the ice is all melted now, and that's the mass at the end. So you can fill those masses in that gap there. Now, is melting a physical or a chemical change? Give 2 reasons to support your answer. So decide on an answer and then go back to this screen to help you give 2 reasons. And has matter been conserved? Has it been kept or lost during melting? You can answer that. The next reaction we're going to look at is a precipitation reaction. Set up the following apparatus and measure the mass. So what I've got here is a bit more complicated. I've got a conical flask. I've got a stopper in the top. I've got a piece of string with a micro test tube, which just means a very, very small test tube. In that test tube, you've got a substance called sodium iodide. And in the conical flask, you've got lead nitrate. Now, they are not mixed. The string is holding up that micro test tube, so it does not tip the sodium iodide into the lead nitrate until we want it to. So on the next 2 slides, it'll tell you the mass. So this is the setup before it's mixed, and you can see the balance here. You can see the conical flask, you can see the stopper, the bit of string coming through, look, and it's tied around that little test tube that's sitting in there upright, and you've got a liquid at the bottom there. So you've got sodium iodide in the micro test tube and you've got lead nitrate there. Now it says to mix both chemicals and record the mass again. So once we've mixed it, look, it's reacted. Can you see now that we haven't got colourless solutions? We've got a yellow solid in there with the liquid. So we've got a yellow solid and a liquid. And keep a note of the mass. So on this page then, you've got the mass of the reactants. That's what you started with. Then you've got the mass of the products. That's what we've ended up with. And then you're going to answer those 3 questions. Name the 2 chemicals you reacted and describe what happened when it mixed. Explain whether you think this is a physical or chemical change. and what happened to the total mass before and after the mixing of the chemicals. Then I want you to go onto this page, heating magnesium in air. Now in the lesson on Moodle for this voiceover, you've also got a video on burning magnesium. So I'd like you to watch that and watch what happens when you burn magnesium. And after the magnesium burns, explain whether you think this is a physical or chemical change. Give 2 reasons to support your explanation. So have a look at the magnesium burning. Does the magnesium look the same before and after? Think about why it does or it doesn't, and then work out whether it's a physical or chemical change and give 2 reasons to support your explanation. And then, if I know you're going to skip a couple of pages now, if you can complete page 48 for me, please, using the information in this PowerPoint, and the words are given to you there. So you've got when wax melts, it is a blank change. So you're going to fill in those words into the blanks there.